Previously, we discussed solubility as being the maximum amount of solute that can dissolve in a given amount of solvent at a specific temperature. So we're going to take this a step further and talk about the ways that we can change the solubility for a substance. So we're going to look at factors affecting solubility. All right, this one seems a little bit obvious, but right in the definition, the solubility is affected by what temperature you are trying to dissolve something in. So let's talk first about temperature. If we're discussing solids and liquids, if we increase temperature, it increases the solubility. As the temperature decreases, your solute can precipitate out. So you're going to see a solid in the bottom. It's not going to look uniform. And if your cooling is really slow, you could potentially have a supersaturated solution, which we talked about in the last podcast. So I like to think of tea when I think of this. So if I have an iced tea and I put a sugar cube into that, I can mix it up a bunch, but I might wind up with some solid sugar at the bottom. However, if I take that same tea and I increase the temperature, okay, that's going to increase the solubility, and so now that tea can hold more sugar than it could. It will dissolve more sugar than it would at a colder temperature. In fact, that's how we make sweet tea. You don't just take iced tea and dump 2 cups of sugar in the pitcher. No, you're going to wind up with a solid layer at the bottom of your sugar. Instead, we take that tea and we boil it, and then we add our 2 cups of sugar because it is at a higher temperature. It's going to have an increased solubility, so it will take more sugar into it. And then we cool it slowly, and that sugar stays in solution. It doesn't precipitate out. So solubility for solids and liquids increases with increasing temperature, and it does the exact opposite for gases. So for gases, your solubility in liquids is going to decrease as your temperature increases. So we have more molecules escaping into the gas phase and fewer remaining in solution. And this doesn't sound like it would be that big of a deal or it would affect anybody, except for it does. And it is a big deal, and you should be concerned. So this is what we consider thermal pollution. So pollution is a result of increasing temperature. So as the temperature increases, the solubility of dissolved gases like oxygen in your lakes and your streams, as that temperature increases, oxygen is going to, there's less solubility for oxygen in the water. So oxygen leaves the water. And I know what you're thinking, there's not that much in there, except for that that's what fish use as their oxygen source. So if we're decreasing the amount of oxygen in our lakes and streams, we're going to start to kill off all of the living organisms in those streams. So it's going to lead to a lack of oxygen for marine life. And this is one of the bigger concerns with global climate change, is as ambient temperatures are increasing, it's forcing this dissolved gas out of water. And what you're looking at here is an image of thermal pollution in a lake where you don't have any living marine life. You have a lot of algae in there. There's no dissolved oxygen. It's pretty much a stagnant lake that hosts no marine life. Another factor that affects solubility is pressure. So again, we're going to separate this and look at solids and liquids and then gases, because gases are just their own beast. So for solids and liquids, changing the pressure has little to no effect on the solubility. So it's not really going to do a darn thing, but for gases, it really does. So solubility in liquids will increase for gases with increasing pressure. So the higher the pressure, the more soluble a liquid is for a gas. And what explains this is Henry's law. So the solubility of your gas in liquid is proportional to the partial pressure of the gas above a liquid. You don't need to know that definition, but it helps us to understand how we get soda. So the higher the pressure, the higher the solubility. And an example of this is how our soda is bottled. So soda is bottled at pressures above 1 atmosphere. 1 atmosphere is roughly the pressure that you experience at sea level. We have a little bit less than 1 atmosphere here, but it's not by much. So they will bottle sodas at 2 or 3 atmospheres. So that's an increase in pressure, which means they're able to get more dissolved CO2, so gas, into that soda. As soon as you open the lid on that soda, you decrease the pressure, which means you decrease the solubility of the gas. And suddenly you have all this CO2 escaping from the solution. It's no longer soluble at that level. And that's where you get the bubbles from your soda. Another example of this is with scuba divers. So scuba divers will ascend, or they will come back up to the surface very slowly to avoid forming bubbles of nitrogen gas in joints and small blood vessels. So nitrogen gas is dissolved in the blood under higher pressures experienced when you're underwater, because as you're underwater, you have more layers of ocean on you there, you experience a higher pressure. When you ascend slowly, this allows the external pressure around the diver to slowly decrease, which slowly decreases the solubility of gas in the blood. I believe this phenomenon is called the bends. All right, finally, the last two factors that affect solubility we'll go through a lot quicker than the last two is particle size and agitation. And I'm going to pull this back to our iced tea example because I think it does such a great job at describing what's going on. So a decrease in particle size results in an increase in solubility. Duh. So think about dissolving a sugar cube into your iced tea versus dissolving just straight sugar granules. It's going to be a lot easier for you to dissolve the sugar granules in a smaller pieces than the sugar cube. It's just going to take longer. And so particle size matters. And it would probably be even quicker if you took powdered sugar and dissolved that, but I don't know what that would taste like. Finally, agitation. If you increase agitation, so think about stirring as your agitation. This will increase solubility as well. So if you just put your spoonful of sugar into your tea and hope for the best, it's probably not going to dissolve, especially not at a colder temperature. So take your spoon and agitate it, and that's going to increase the solubility of the sugar in the tea. In fact, again, let's go back to it. You want to dissolve more sugar in your tea, start increasing the temperature and use granules and stir, and you're going to be able to get more sugar into your tea. You're welcome.